We've talked a fair bit about Azure ML on this channel, but what does Microsoft actually bring to the table here? Welcome to this video on Azure Machine Learning. My name is Kevin Fiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm that specializes in work all across the data platform space, especially SQL Server. Over the course of a dozen or so videos, we've learned how to do a fair amount of work in Azure ML, starting with simple operations like the creation of compute instances and clusters, and moving up to automating MLOps processes with GitHub and Azure ML. Today, I am going to focus on answering a great viewer question. To summarize this question, you can perform every critical machine learning operation, from training and testing the model to serializing it, wrapping it in an API, and deploying. So what exactly is Azure ML doing here, and what's the benefit for somebody who already knows how to perform each of these steps without AML? I like this question in part because it is not trivial to answer. I can't say, oh, Azure ML provides this capability you won't find anywhere else on the market, or Azure ML beats every other contender in this critical measure. There's a lot more to this story, so let's break it down. And the easiest way to break it down is to jump right into a demo and show it from the Azure Machine Learning Studio. So let's go over there. I'm going to focus on the core components of Azure ML today, so I won't get into generative AI components in today's video. To that extent, let's look at what Azure ML has to offer and how it compares to the broader world. On the left-hand side, we have our core components. In the Manage section, I'll start with Compute. As a brief reminder of things, compute instances are essentially data science VMs for individual members of your team. Can you build a data science VM or laptop on your own? Yeah, absolutely. But there's going to be some time and effort involved, as well as a need for hardware. Meanwhile, if I need more hardware, I can select this New button and spin up something in just a few minutes. I can even create custom installation scripts to install applications, so that way my new VM has what I need already installed. This is, I think, one of the biggest benefits to any cloud service over on premises. You can quickly trade money for hardware. And with Azure ML in particular, you're trading money for hardware and the time it would take you to configure all of this stuff. Moving over to compute clusters, we have a similar story at a higher level. Our compute clusters allow us to perform training and inference across multiple machines, including machines with GPU support configured. And one nice thing about this interface is that I can keep track of all of my available compute clusters and what work they're performing right now, something I might not be able to do very easily on premises. That's the overview of compute. Do we need Azure ML in order to create data science VMs or clusters we can use to train or score models? No. We could certainly build those ourselves. But what Azure ML does is that it makes life easier for us, to the point where I can spin up a cluster with a few mouse clicks, or even I could create these clusters programmatically. Here in Visual Studio Code, if I open up the deploy train Python script and scroll down to line 51, we can see the command to create a new Azure ML compute cluster via the Python SDK. It's a single function call to allocate a cluster as part of a script. The power here is in its relative simplicity. Now let's go back to Azure Machine Learning Studio and hit the next major component, data. Data is in the Assets section, and it's made up of 3 tabs. First, let's talk about data stores. As a quick refresher, data stores are pointers to specific Azure services that we can use to store data. This includes file storage mechanisms like Azure Blob Storage or Data Lake Storage, as well as Azure databases for SQL Server, MySQL, and Postgres. These are Azure-specific assets, but the benefit is we can securely connect to these without providing credentials in our notebooks or scripts. Switching over to Data Assets, this tab allows us to track the data sets our data science and machine learning teams use in one location and allow team members to reference these without needing to know exactly which storage device hosts the data. If you already know where all of your data sets are, or if they all live in one location, this may not sound like it's a great benefit. But as a team expands and as we work in more complex environments, having everything in a single location can help. Also, there's a third tab I haven't really talked about yet: dataset monitors. Now, we won't get into this much today, as I do have a video planned on the topic. The really short version of dataset monitors is that you can track whether the distribution of your inference data becomes significantly different from your training dataset, as this could be an indicator that it's time to retrain your model. The upshot to all of this is similar to the conclusion from the compute section. Azure ML doesn't provide us with anything we absolutely cannot recreate on premises or in another environment, but it does allow us to systematize our dataset locations and even, in certain circumstances, track dataset drift. When it comes to automated machine learning, I think using Azure ML is one of the easiest ways to do this. As we saw in a prior video, there is a step-by-step interface we can use, and AML takes care of all of the testing, inference, and evaluation. Automated ML is not a replacement for proper data science and machine learning development, but it is great at building a baseline and can be a useful first step before spending hours or days fiddling with a problem. From there, we have two methods of building our solutions: a drag-and-drop designer and a code-first approach. I won't dig into either of these here because we've had several videos to cover these approaches. Neither approach is unique to Microsoft. After all, tools like Alteryx can do drag-and-drop model training, and of course we can write code in languages like R or Python to implement machine learning tasks. But a strike against Azure ML's code-first approach is there is an additional amount of ceremony that you have to add to the code to get it to work. In the Beyond the Basics with Azure ML codebase, there's a lot of code that serves to prompt AML rather than solving the ML problems directly. Most of the deploy train and deploy score files and all of the config files serve to tell AML what's going on. Hand training a scikit-learn job on your own local compute is simpler. I don't really doubt that. Microsoft does try to mitigate this with a large set of examples, and I think they're partially successful here. The problem is, there are so many different scenarios for AML to cover that the set of solutions can get really confusing. I'm willing to chalk this up as necessary complexity to make sure Azure ML is a general purpose solution rather than custom code intended to solve one specific problem. Back in Azure ML Studio, we'll continue our foray into why you might want to choose it versus rolling your own solution. The Jobs and Models options in the Assets submenu do tie together, as they serve as an alternative to hosting your own MLflow server. The Jobs tab lets us look at experiments and individual runs, including the ability to review metrics and even see the code we ran. This is great for troubleshooting and auditing purposes, and there's very little we need to do to our code to make this useful. Azure ML follows the MLflow standards for function calls like log_metric. We can then review those metrics in Azure ML. Can you do this another way? Yeah, of course. You could use MLflow directly or rig up your own logging system. But this approach is easier for a data scientist because there's no service administration or custom logging solution in play. Similar to Jobs, the Models tab lets us track versions of models using standard MLflow terminology and function calls. Drilling into an individual model lets us learn more about how we created it, jobs and experiments associated with it, the different artifacts our model creation process generated, and even the ability to deploy it with a few mouse clicks. Once you do have a deployment in place, you can manage it in the Endpoints tab. I think this experience is a lot smoother than endpoint management if you simply roll your own Flask or Fast API services running in Docker containers. We can see which endpoints are available and learn more about them. For real-time endpoints like this Chicago parking tickets one, Azure ML will auto-generate some test data for us so we can learn a little bit about what the endpoint requires. In the Consume tab, it will also give us sample code for Python, C#, and R. Now, I do take off points for not including F# on this list, but otherwise this is quite useful. Once again, we ask the question, could we do this ourselves? The answer is yeah, of course we can, but it would take extra effort to maintain. Summarizing this, where I stand on the matter is that Azure ML offers nothing absolutely unique. but it does offer a lot in a single location and can simplify the steps of the machine learning process that you're not as familiar with or maybe comfortable with. If you don't have a solid data processing foundation, AML offers the concept of data stores and data assets, letting you track and manage data. If you don't have the hardware available, AML makes it easy to build data science VMs, that is, compute instances, and interlinked training machines in compute clusters. We can also get access to GPU-based machines for these clusters. If you're not as strong on the data science side of things, training and scoring models via automated ML or a drag and drop interface is available. If you're not running MLflow locally, AML can act as a model registry and packaging solution. If you're not strong at API development, AML gives you a pretty straightforward framework for that. If you're not strong at container and server administration, Azure ML containerizes and deploys container images, and then Azure Kubernetes Service or Azure Container Instances can host. And if you are strong at all of these, AML gives you an interface where you can track all of this stuff in one location rather than a dozen different tools or web portals. Now, in the next video, I'm going to show off a bit of functionality that I haven't really talked about to this point. We're going to use Power BI to consume data from Azure ML. There's a direct tie-in that makes it kind of easy. Spoilers for the next video, but we will see how that works. As I wrote out the script for this episode, I kept coming back in my mind to those old BASF commercials. We don't make the product, we make it better. And I think that's the selling point behind Azure ML as well. Very little of what you find in Azure ML is unique to the product or was invented by Microsoft as part of Azure ML. There are a few things, and to my recollection, Decision Jungles, for example, is an algorithm that Microsoft invented and originally put into Azure ML. But in general, what Azure ML does is that it puts together all of these individual components in a way that a team of people with a variety of skill and experience levels can cooperate on performing tasks. For the parts of the data science and machine learning processes that you know extremely well, yeah, you can probably find an easier way to perform many of these tasks. But for the parts you're not as comfortable with, including administration and monitoring, that's where Azure ML steps in and helps out. We'll have links and show notes in the description below, and until we see each other in the next video, take care.